Hello and welcome to lesson 2H. We're going to talk about piecewise functions in this lesson today. And what a piecewise function is it's a function that's defined differently for different values of x. So for example, this first function, f of x, it's defined as 3x plus 2 when my x value is less than 0. But then if my x value is greater than or equal to 0, it's going to act like 2x minus 1. So if I want to find f of 4, well, I need to figure out for where is it defined at 4. That's when x is greater than or equal to 0, so it's defined as 2x minus 1 there, be 2 times 4 minus 1, which is 7. Whereas if I want to find f of negative 3, well, that's behaving that way in this range here, so it would be 3 times negative 3 plus 2, or negative 7. Whereas if I'm looking at f of 0, well, this is strictly less than 0, whereas this piece is less than or equal to 0. So we're going to behave as 2x minus 1 over that range. So f of 0 is equal to 2 times 0 minus 1, or just negative 1. So now I want you guys to pause and do this try me right here. And you should have gotten f of 2 is negative 1, f of negative 4 is negative 12, and f of 1 is 3. We can also graph piecewise functions, and the best way to graph a piecewise function is to treat it as a function and then have your eraser out to back out the parts you don't need. So for example, this function is defined as x squared if x is less than or equal to 2. Well, if I were just graphing x squared, that'd be 0, 0, 1, 1 mirrored, 2, 4 mirrored, and then 3, 9. But I'm looking, I only need it when x is less than or equal to 2. The less than or equal to 2 tells me you're going to have a closed dot on 2. Boom. And that's where my function's going to end. But then we're going to back up and do everything that's less than or equal to that. So that's that piece of my function. Whereas this next piece of my function, 3 halves x minus 5 if x is greater than 2. Well, if I were just graphing this as normally, I would start at negative 5, and then I would use my slope up 3 over 2, up 3 over 2, so on and so forth to get a line. Now I only want it when x is greater than 2, which means I want an open dot when x is 2. Well, when x is 2, I get this place right here. So I'm going to replace that with a nice open dot right here. And I don't want the stuff that's behind the 2. I only want the stuff that's going out towards infinity. So I just want this piece of my graph, and I don't want to keep that. So this is the complete graphed solution for this piecewise function. All right, guys, I want y'all to pause now and do this example. All right, guys, go ahead, take a minute and check your work. Okay, let's take a look then at transformations of piecewise functions. Now, these guys are just ugly looking functions, but they're really useful to help you get the idea of how transformations really work. So this is a lovely piecewise function. It's not lovely at all, actually, it's quite ugly, but it is what it is. It has a domain between negative 2 and positive 3, because that's where my x values are. Between negative 2 and positive 3, and my range, the lowest I go is negative 1, the highest I go is 3, so my range looks like that. Now, we're now going to take this piecewise function and we're going to transform it in a lot of different ways. And the first thing I always want to do is I want to identify what kind of transformation am I doing. The light gray is the original function, which will help us see what's going to go on here. If I have f of x plus 3, when you have plus 3 outside of the f of x, we learned a couple lessons ago that this is a vertical translation. And what that really means is we're going to go up 3, okay? So each of these points is going to go up 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3, and then I just connect it. And if you notice, it has the exact same size and shape, we just shoved it up 3 units. My domain in all of this did not change. I'm still going between -2 and 3, but my range, on the other hand, all went up 3 units. So now my lowest value is now at 2, and my highest value is now all the way up at 6. That makes sense because a vertical translation impacts my y values only and sends them all up 3 units. Let's take a look at this guy. When I've got a number out front multiplying my function, this is going to act as a vertical stretch. And what a vertical stretch does is it's going to multiply all my y values by 2. So here, my x value of -2 isn't changing, but the y value of 1 is going to become a y value of 2. Here, my x value is -1, which doesn't change. My y value is 0. Well, 0 times 2 is 2, so it stays right there. X value is 0, doesn't change. Y value of 2 becomes a y value of 4. My 0.13, my x value of 1 doesn't change, but my y value of 3 becomes a y value of 6. Again, we have another y value of 0, so he doesn't change. And then I've got an x value of 3, a y value of -1. So that -1 now is going to be multiplied by 2 to become -2. So when we connect all of our dots, it looks like our function has been stretched on the vertical axis. So when we now consider the domain, my domain didn't change. I didn't do anything to change the x values. It's still -2 is less than or equal to x is less than or equal to 3, whereas my range is now stretched by 2 units. It's that was wrong. -2 is my lowest y value, and my highest y value is now 6. So if we're comparing that to the very first one, between -1 and 3, now we're between -2 and 6. All right, moving right along. This guy right here, I really like this. When we put a negative out front, this becomes a vertical reflection. And what a vertical reflection does is it's going to change, the y values are all going to change sign. Y values change sign. They flip over the x-axis, right? So this first point here, -2, 1 becomes -2, -1. -1, 0 stays -1, 0 because you don't, 0 has no sign. 0, 2 becomes 0, -2. 1, 3 becomes 1, -3. Again, the 0 doesn't change. And if we have a y value of -1, now it's a y value of +1. So now it looks like this. And so now when we're considering, again, the domain didn't change. My domain is still between -3 or -2 and 3, whereas my range is a bit different. Now the lowest value hit on the range is now -3, and the highest value is now +1. So comparing this to up here, it's the negation of this with signs flipped. Moving right along. Now we're going to start messing with the x's, which we haven't gotten to do yet. This guy right here, when we put a negative inside the parentheses, this is going to be a horizontal reflection. And what that means is that my x values are going to change their sign. Not the y values, just the x values. So here, -2, 1 is going to become, if we're 2 away from the y-axis, we're going to go 2 over to the other side. 2, 1. -1, 0 is now 1, 0. 0, 2 stays 0, 2. 1, 3 is now -1, 3. 2, 0 is now -2, 0. And 3, -1 is now -3, -1. So what happens is we get basically, that's a really bad join line, we get a graph that's been reflected over the y-axis, where all of my x values change sign. When we're looking now at my domain has changed. Now we're going between -3 is less than or equal to x, which is less than or equal to 2, whereas my range hasn't changed. My lowest value is still -1 for the y, and highest value is 3. So this next graph right here, when we're inside the parentheses, this becomes a horizontal translation. But with a horizontal translation, we do the opposite of what we think we should do. So if it's saying +3, that really means I'm going to go left 3. So that means each of these coordinates here is just going to get shoved left 3. So this guy, we're going to go left 1, 2, 3. Done. Left 1, 2, 3. Done. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So when I join them all together, it hasn't changed anything about the y values. My y values are all still the same, but my x values all went left 3, which means now that my domain should be left 3 of where it was before. My smallest x value is 1, 2, 3, 4, 5. -5 is less than or equal to x, which is less than or equal to now 0. And my range hasn't changed. My lowest y value is still -1. My highest y value is still 3. Okay, now we're going to start doing slightly more complicated things. Here we have two things going on. The first thing we have in this picture is we have a vertical compression. And the reason it's a compression, not a stretch, is that it's less than 1. And when you've got a vertical compression, that means that all your y values are going to be multiplied by whatever that number is, in this case 1/2. Then the other thing we have in this picture is we've got a horizontal translation. And when we're, I spelled that wrong already, translation. And this horizontal translation is a -3 inside the parentheses. When it's in the parentheses, we do the opposite that we think we should. So we're going to go right 3. I recommend doing this guy in 2 steps. I'm going to deal with my vertical compression first, and then I'm going to translate everything right 3. So if I take all of these y values and multiply them by 1/2, 1 becomes 1/2, 0 stays 0, 2 becomes 1, 3 becomes 1.5, 0 stays 0, -1 becomes -1/2. So we get just like this really squished looking graph. And now I'm going to take all of these new points, my red, and I'm not going to translate everything right 3. So this point's going to go right 1, 2, 3, and graph. This guy's going to go 1, 2, 3, and graph. He's going to go 1, 2, 3, and graph. This point, that 1.5, is going to go 1, 2, 3, graph. Then this guy, 1, 2, 3, and my last point, 1, 2, 3. So my domain and range are both going to change now, because my domain changed by everything going right 3. Now the furthest to the left we go is 1, and the furthest to the right we go is 6. Everything went right 3. Whereas with my range, everything got squished. The lowest we go now is -1/2, and the highest we go is 1.5 or 3/2. All right, let's take a look at this next one. When you've got a number inside the parentheses like this ends up being a horizontal stretch or compression. This one is actually a stretch, because remember, it's always the opposite of what we think it should be when it's in parentheses. So if I have a number less than 1 multiplying my x value inside the parentheses, it's actually going to be a stretch. If it was a number greater than 1, it would be a compression. And because we always do the opposite of what we think we should do, this is a 1/2 multiplying the x. So we're actually going to divide my x values by 1/2. Which, guys, think back to middle school. Dividing by 1/2 is the same as multiplying by 2. So really every x value is going to get multiplied by 2. Y values are not changing. So this first x value here is -2. And so -2 is going to become -4. My next x value is -1. -1 is going to become -2. Notice I'm not changing my y value. My next x value is 0. Well, 0 times 2 is 0. My x value of 1 becomes an x value of 2. X value of 2 becomes an x value of 4. And an x value of 3 becomes an x value of 6. So when I join all my points together, what it looks like is that I have taken my graph and I have pulled it horizontally. I've made a horizontal stretch. So when I'm looking at my domain's going to change. Everything got pulled outwards. Now my lowest x value is -4, and my highest x value is now 6. My range, on the other hand, did not change. I'm still going between -1 and 3 for my y, because I did nothing to impact the y values. All right, let's look at this guy. Oh, I like this one. This one's fun and easy. This one has 2 translations. This is a horizontal translation, and this horizontal translation, remember we do the opposite of what we expect, so it's going to take all my x values left 2. Whereas this one here is a vertical translation. And when it's outside my parentheses, I do exactly what I expect. So this is going to go down 4. So what I can do is each of these points, I can take them left 2, then down 4. So this point's going to go left 2, down 1, 2, 3, 4. This guy's going to go left 2, down 1, 2, 3, 4. Left 2, down 1, 2, 3, 4. Left 2, 1, 2, 3, 4. Left 2, 1, 2, 3, 4. Thank you guys for your patience. All right, here we go. And we are graphed very nicely. Y'all can find the domain and range of that on your own. So I want you guys right now, what's the domain? What's the range? I want you guys to write it in. Okay, let's take a look at this next one. I've got f of x equals, or y equals f of -x plus 3. The negative x is a horizontal reflection, which means all of my x values are going to flip over the y-axis. Flip over y-axis. And then I've got on the outside here, this is a vertical translation. And what that means is that all of my y values, we're going to go up 3. This is one that anytime you're mixing types of transformations, I recommend doing it in 2 steps. You can do it in 1, but I get confused personally when I do that. I like to do them in 2 steps. So I'm going to do my horizontal reflection first. So 2 away from the y-axis is going to become 2 away on this side, 1 away, stays, 1 away to 1 away, 2 away to 2 away, 3 away to 3 away. So the red is just f of -x. That's all this is right now. And notice it's just a clean reflection. And now I'm going to take the red and I'm going to shift it all up 3 units. So this is going to go up 1, 2, 3, 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 1, 2, 3, to get our final graph. So the green is the final. The green here is the final version of this graph. So if I was looking at the domain of this thing, well, my domains have flipped because we did this horizontal reflection. We're now going between -3 and 2 on the x-axis. And my range, on the other hand, has also moved, but it's been shoved up. So now my lowest point, where before it was -1, now my lowest point is +2. And my highest point is now 6, because we went up 3 units on the y direction. All right, guys, last one. Thank you for hanging in there with me. Here we go. This last one, I also have 2 things going on. This is a vertical stretch, which means we're going to multiply your y values by 2. And then this here is a vertical translation because it's outside, and vertical things always do the thing we expect them to. Translation. So he's going to go down 2. So let's do just that. I'm going to do the stretch first and then the translation. I'm going to do it in 2 steps just because it makes me happier. So this y value was 1. Now it's going to be 2 because we're multiplying by 2. Y value of 0 stays 0. Y value of 2 becomes 4. Y value of 3 becomes 6. Y value of 0 stays 0. -1 becomes -2. So that's just the stretch. And now I'm going to translate all of that down 2 units. So we're going to go from here, down 2 units, graphs to here. This guy, down 2 units, graphs to here. Down 2 units, down 2 units, down 2 units, and down 2 units. So we get this graph. My domain has not changed. We haven't shoved it left or right any. So my domain is still between -2 is less than or equal to x is less than or equal to 3, but my range has changed quite a lot. My range, the lowest point is now 1, 2, 3, 4, -4, because we multiplied the lowest value -2 by 2, and then we took it down another 2 points. And my highest value is now 1, 2, 3, 4 as well, because it was 3 before. When I multiplied 3 by 2, it became 6, but then we brought that down 2 more. All right, guys, thank you very much for watching this video. Take a look at the worksheet, and y'all have a great day. Thank you.